So let's do a cube of a binomial. So this pattern, let me just give it to you, is a cubed plus 3a squared b plus 3ab squared plus b cubed. And then for the a minus b cubed, that is a cubed minus 3a squared b plus 3ab squared minus b cubed. And so looking at this, there is a pattern here. And so this is the numbers that we're going to multiply. And let's take a look at this. So for z plus 3 to the third power. Now remember how you have to multiply that. If you were to multiply it all the way through, what you first have to do is you have to multiply it by expanding it. So z plus 3 times z plus 3 times z plus 3. And so you would multiply this first. And then after that, you would multiply whatever that is to this last thing here. Now we're just going to apply the pattern. Now for now, if you're still not comfortable with this, then you can go ahead and multiply it through by doing this multiplication. But I want you to stretch yourself and really trying to use this pattern. Again, when we look at Pascal's triangle, we're going to look at higher powers, meaning that this power is going to be a 4 or a 5. And so it's not very efficient if you're just trying to multiply it through instead of trying to use the pattern. So in this case, remember our pattern is here. So A is z and b is 3. So we're going to plug it into this pattern here. So a cubed, that is z cubed plus, let's write 3, times z, and then that's squared, times b, which is 3. Then we have the pattern plus 3, and then a is the z, b is the 3, and then that is squared, looking at the pattern, plus b cubed, and b cubed is 3, so we're going to write 3 cubed. Okay, so notice where we plugged it in. We're just plugging the a and the b in there. So now let's simplify. This just stays the same as z cubed plus 3 times 3 is 9z squared. Then 3 squared is 9. 9 times 3 is a positive 27z. Then 3 cubed, that is 27. So instead of having to multiply it through, then that is the shortcut. And I know some of you like shortcuts, so that is very useful. So this last one, m minus 2 cubed. So what we're going to do, again, just plug in the numbers, leave the signs as they are. So just apply the signs. Don't change them. And I think that's the most common error students make is they go, oh, I need to plug in a negative. And you actually don't. It's already there for us. If you want to plug in the signs, then just plug it into the original ab cubed, and then that does change the sign, and you notice it is this same exact pattern. Now I'm just going to use this pattern. So m, that's our a value. A is m. And then b, I'll do it in different colors. B is just a 2. So we're going to plug it into this pattern. So a cubed, that is m to the third power, minus 3, and then our a value is m, and that is squared, and then times b, which is 2, plus 3 times our a value, which is m, times b, which is 2, and then minus b cubed, which is 2 to the third power. So let's simplify. This is m cubed minus 3 times 2 is negative 6m squared. 3 times 2, and that's supposed to be squared, sorry. 3 times 2 squared, so 2 times 2 is 4. 4 times 3 is 12m. And then 2 cubed is a minus 8. So your final answer is m cubed minus 6m squared plus 12m minus 8. Now, in order to show the proof of why that is, we're going to prove the polynomial identity for the cube of a binomial representing a sum. So we're going to multiply this. A plus b cubed equals a cubed plus 3a squared b plus 3ab squared plus b cubed. So that's what we should get. So we're going to prove it by actually expanding and simplifying. So let's do a plus b to the third power, and then we're going to expand it. A plus b times a plus b times a plus b. Now this is where that special product pattern comes in, but I'll just go ahead and do it the long way. So we're going to multiply this section first. And so let's see. First, a times a is a squared. A times b is positive ab. Then b times a is a positive ab. B times b is a positive b squared. That's all multiplied to a plus b. Then let's just simplify this a little bit more. This is a squared plus, there's 1 and 1, 2ab plus b squared, and then multiply that to the a plus b. So I'm going to distribute that. So I'm going to do a times a squared plus 2ab plus b squared plus b times a squared plus 2ab plus b squared. And so this becomes a cubed plus a times 2ab is 2a squared b plus ab squared. Then this right side is a squared b plus 2a, and there's two b's, b squared plus b times b is b cubed. So then we simplify all the way. This is a cubed. Then we have 2a squared b. There's another one here. 2a squared b and a squared b. That becomes a 3a squared b. Then plus 2ab squared plus 1ab squared. That's a 3ab squared. And then plus b cubed. And so now we prove that identity, and so that really does work. Now you could do this one, although I already did it already, you could expand this one. Now if you want to try something a little more challenging, try to prove the a minus b cubed, and that should equal a cubed minus 3a squared b plus 3ab squared minus b cubed. Try this one out. Okay, for this one, I used the box method and then also used the vertical method to multiply, and maybe that's something that makes a little more sense to you. But if we were to multiply this all out instead of using the pattern, notice how much more work this is. Now it's up to you, whichever method you would like to do for now. Again, I would like to stretch yourself. Try to use the pattern. I know that it's hard, but as you get a little bit more comfortable, then you will get used to it.